Right. Okay. I'm back to take us through integration. Hope we are doing well. Okay. So, this is our last section of this topic. Yeah, and we've seen derivatives, how we differentiate a function, a variable in respect to another variable. Yeah, but at times, if you want to go back to the original function, then we use integration, or we integrate. So integration is the opposite of differentiation. Okay, so integration and differentiations are opposites, or integrals and derivatives are opposites. Okay, so if I have my x squared, if I differentiate, I'll get 2x. Yeah, but if I'm interested in knowing how I got my 2x, or the original function which gave us the 2x, then we integrate. Yeah, as you can see in this illustration. Okay, we had x squared, and then we had a derivative, and it gave us 2x. All right, so if you want to go back to the original function, then we integrate. So I'm just going to introduce us to integration. I won't go deep. I'll just take us through a few rules, the principal rules. Yeah, you can go on and read more, okay, about the integration by parts and so on and so forth. I'm just going to take you through the first rules. Okay, and that's the power rule. Yeah, I'll start with the power rule. Okay, recall we had a power rule in derivatives, or when we're differentiating, we had a power rule. For the power rule in differentiation, we said we multiply by the power and we subtract 1 from the power. Yeah, so to redo that, we have our power rule in integration. So for the power rule in integration, you add 1 to the power and then you divide by the new power. That's the power rule. Under derivatives, we multiply by the power and you subtract 1 from the power. Okay, so for the integration, you add 1 to the power and you divide by the new power. For instance, the symbol of integration is this stylish S. And just to go back a bit, integration, the symbol of integration is this stylish S. It's like a snake, it's like a sleeping S, you know? Yeah, S, sleeping S. Yeah, that's the one which represents integration. This is the symbol of integration, that is you're seeing. Okay, so for instance, if we have we are differentiating, we're integrating x to the power n. Yeah, this is how the symbol will look like, or this is how it will look like. Okay, yeah, so if we are integrating this, the rule is you add 1 to the power and you divide by the new power plus the constant. And this c, you always have to add that c, that constant. Recall when we are integrating, when we are differentiating, every constant becomes 0. Alright? Meaning we can't trace that constant. Recall the role of integrating is to trace, to go back to our original function, which gave us a derivative. Yeah? So in case that that function had a constant, that constant diminished, it became a 0. So to cater for that, we put a c. So this c is to cater for that constant. Yeah, which diminished. So we are not too sure about it in this case, for we can't recover it. Yeah, we can't recover it. So we put a c to stand for that constant, which became a 0 when we're differentiating. Okay. Yeah, so that's the power rule. You add 1 to the power and you divide by the new power. E.g., if you have x cubed and you want to get the integral of x cubed, how do you do it? Okay, so like you can see, it's x to the power 3, meaning we have to apply the power rule. We have to use the power rule. So yeah, okay, this is just to bring back the formula. So if it's x to the power 3, it's then x to the power 3 plus 1 divided by 3 plus 1. Recall we said we divide by the new power. Yeah, so it will now be x to the power 4 divided by 4 plus our constant. That is our answer. So something which is simple. Yeah, something which is simple. Yeah, so that's the answer. That's the answer. Okay, let's move on and look at other examples. Actually, you can try with the examples you differentiated and you see if it gives you back. I'll try out one. We'll try out one on the actual number we differentiated, or the actual function we differentiated. We'll integrate it and see if we'll get back to that number. Okay. Alright. Okay, this is another example. If we have this, recall this is the same as having x to the power half. X to the power half. Yeah. So x squared. No. X. The cube root of the square root of x is the same as having x to the power half. Yeah, the square root of x is the same as having x to the power half. So if you know you're having x to the power half or x to the power 0.5, the rule is very simple. You add 1 to the power and you divide by the new power. Yeah, first plus our constant. Yeah. So if you are having x to the power half of the power 0.5 and we add 0.5, I mean we add 1 and we divide by the new function, or the new number we'll get. Okay, the new power. So it will be x to the power 1.5 divided by 1.5. We said we divide by the new power we'll get, and then plus our constant. That is x to the power 0.5, or the square root of x. So the square root of x, the integral of the square root of x is that. Alright? Okay, so before moving to any other rule, like multiplication by constant, let me pick out an example we had earlier, for which we got the derivative, and then we integrate it and see if we go back to our original answer. Okay, let me take an example. Let me get one of the first ones. 4x to the power 4. Okay, 4x to the power 5. It gave us 20. Okay, this. So let's see if we are given this function. Let's see if our answer will be 4x to the power 5. Yeah, I want us to see if our answer will be 4x to the power 5. I want us to see if our answer will be 4x to the power 5. Okay, let me put here in this slide, and then I want to see if our answer will be that. Okay. Yeah, I want us to solve this. Yeah, we have solved that. We said the rule is simple. You add 1 to the power and you divide by the new power. So this will be, let's have it, we copy it, and we put that. Let me hope I've copied the actual number. Let me hope I've copied the actual number. It was 30x to the power 4. I want to see if you get so want to go back. Yeah, this is the answer you got when you differentiated a certain number. So want to see when you differentiate a certain function, want to see or want to get back our original function, and you do that by integrating. So let's do it. Okay, so the rule is simple. We add 1 to the power, so it would be 4. We are adding 1 to the power, so the power is 4. We add 1, okay, and then we divide everything by the new power. So we have to divide everything. We have to divide everything by our new power, which is 5. Or this is the same as, let me just insert some symbols. I insert an equation here. Yes. Alright, So on is this, copy, I paste it there, over 5. Alright, so we are having that 20x to the power 5 divided by 5, divide by 5. Okay, so this would be this 5 will cancel into the 20, so it will become 4x, to become 4x. Hello, yes please, I'm in the first office. Okay, so it will be 4x, 4x to the power 5. It will be 4x to the power 5. It will be 4x to the power 5. It's 4x to the power 5. 4x to the power 5. 4x to the power 5. Okay, so yeah, so if you can see this, our 4x to the power 5, now if you compare with our earlier function, or the function we differentiated was 4x to the power 5, and then the derivative we got was 20x to the power 4. So after integrating 20x to the power 4, we are seeing ourselves going back or getting back our original function. So that's how integration works. But first, plus our constant, we add a c plus our constant just in case, plus our constant. So that's the power rule of integration. That's the power rule we're talking about. Alright, so now I'm going to look at a few two more rules under integration. I'm going to look at 2 more rules under integration, and then I'm going to look at 2 more rules under integration. The other rule is the multiplication by a constant. Okay, multiplication by a constant. Yeah, here we are seeing, recall this sleeping s, or the snake s, stands for integration. Yeah, it stands for integration. It stands for integration. Yeah, so assuming you're having our function like the x squared being multiplied by the 6, which is a constant, how do you deal with that? It's simple. Yeah, we pull out the 6. We can pull out our 6 and we have it at the front. Alright, and then we apply our earlier rule. Yeah, so we pulled out our 6 and we brought it the front. Yeah, and now we can use the power rule on x to the power 2. We can now use the power rule on that x to the power 2. Yeah, so if we do so, we are having 6, the one with the constant x. Yeah, okay, there's a step here which I should add. Yeah, because someone may wonder, hey, how do we reach that side? Okay, so let me add a step. 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 So it's this. Let me add a step. Yes, sir. Hey, it's inside here. Okay. Alright, too sorry about that. So I was showing you the step I'd skipped, and the step I'd skipped. Okay, so it's x squared plus 1. Recall we said you add 1 to the power, and then we have the new power, which is 2 plus 1. So it's this which gave us that. Okay, so from this we got x cubed over 3 plus c. Okay, which we can simplify to 2x cubed plus c. Altogether, this 3 cancels off with that, so it becomes 2x cubed plus c. So that's the multiplication by constant. You just put that out and then you apply your other rules. So integration is simple. Yeah, provided you know these basic rules. Okay, so I'll ask you to go and use to do this number using the sum and the difference rule. It's very simple. If I'm having this function, then that means you're going to deal with this, the integral of that plus the integral of that minus the integral of that. Please try it out and share with me. Try it out and share with me. We are going to apply the earlier rules, but of course we'll be adding and then subtracting. Thank you very much for listening. Thank you.